Welcome to myprojectbazaar.com. Our product is design and development of Matlab based 3-phase converter for unbalanced AC source with enhancement in power. Let us see about the abstract of our product. The main objective of this project is to design of control circuit with the zero sequence components, but the proposed system will enhance the power control ability in the adverse condition. The power converter is implemented with the new control technique. In the current component, zero sequence components is controlled to reduce the unbalanced nature of AC source. This power converter have the ability for the flexible control target that produces the better output power and load current during unbalanced AC source. This project will have more accurate result than the existing system. 3-phase DC to AC power converters suffers from power oscillations and converters suffer from overcurrent problems. In case of the unbalanced AC source voltage that can be caused by grid and generator faults, existing solutions to handle these problems are properly selecting the controlling the positive and negative sequence currents. In this proposed implementation is a new series of control strategies with utilize the zero sequence components are proposed to enhance the power control ability under this adverse condition. It is concluded that by introducing proper zero sequence current controls and corresponding circuit configuration, the power converter can enable more flexible control targets, achieving better performance in the delivered power and the load current when suffering from the unbalanced AC voltages. And main thing in this proposed implementation is only done for the given flow diagram and also the flowing and also corresponding waveform only here we provide. Next we see about the flow diagram of our product. Here the input source is a DC source. The DC source is a DC bus is fed into DC to AC converter. Using of DC to AC converter that convert the form of electrical energy from another form of electrical energy, and also using power electronic switches. In that power electronic switches is triggered from PWM generator. In that PWM generator is a space vector pulse width modulation technique, and also after that the output of the DC to AC converter is fed into the LC filter. LC filter is nothing but inductor and capacitive is connected in the filtering purpose, and also that output is fed into the grid. Here that voltage and current waveform is getting by using of sensors, and that the comparator is used to calculate the error, then that is fed into the PWM generator. But in that proposed work we only getting the output voltage waveform not connected to feedback unit is using to space vector pulse width modulation technique. But in the flow here we showing the PWM generator in the feedback control, but in the implementation we only did the space vector pulse width modulation for DC to AC converter process. And also in the filtering is used for remove the unwanted harmonics and also the unwanted signals in the output voltage and current waveform. And also in the grid is already connected from various generating stations. Then in that grid voltage is have some much of voltage and current, and also this converted AC voltage is to connected with the that grid side. So the voltage and current waveform will be changes using of that connection of the point of coupling. Next we see about the running process of our product. In this proposed implementation is done in Matlab simulating environment. First open the Matlab main window. After that we creating a new model file. After opening the new model file we are assigning the name and also then check the solver conditions. After that we opening the simulating library browser. From that library browser mainly we use two toolbox. One is the sim power system, another one is the commonly used block. From that blocks we getting the elements and then arranging the elements in the model circuit, then given flow diagram basis. Then after arranging that elements, we connected the scope from the commonly used box. In that, scopes are connected across the measuring devices. After connecting that, we click the run icon. Then the simulation will start to run. After entered the simulation, we open the scopes. Corresponding output will be shown in the corresponding scopes. So first is the input current waveform, and next one is the input voltage waveform that range is 600 volt, and this is the inverter output grid side output voltage and current waveform. So here we can see the voltage is 350 and the current range is above 6000 amps, and also that reached to 2000 amps before of connected the grid side. So the voltage and current variation, so like this much. And next one is the inverter side output voltage and current waveform. Here the voltage is high and also the current waveform also high, 2000 amps and also the 400 voltage. So this is the pulses waveform is generated for power electronic switches to trigger. So here we using space vector pulse width modulation technique. So in this inverter having 3 legs, each leg having 2 power electronic switches, each does not trigger in the same time. We can see in the pulse waveform. So this is S1, those two scopes are connected in each leg, so the waveform will be differed. This one is on that time, this one is off, and also this one is on, and also this one is off. So this much similar to all waveforms are generated and also corresponding to connected to the power electronic switches. Thank you for watching this video.